This content has been specially prepared for World Peace TV Neuroscience, aiming to deepen our understanding of the brain's size, energy use, and protective mechanisms. It is part of a greater effort to promote global knowledge and appreciation for the incredible organ that shapes who we are. The brain, although it accounts for only about 2% of the body's total weight, demands a disproportionately large amount of the body's energy to function. Its operations are so complex and continuous that the brain remains active even when the body rests, fueling dreams, unconscious thoughts, and vital processes. To support and protect such an essential organ, the body has developed several mechanisms, including protective membranes, a sturdy skull, and specialized fluids that cushion the brain from physical shocks. On average, the human brain weighs about 3.5 pounds, or roughly 1.5 kilograms. Its size and texture resemble that of a medium-sized cauliflower, with a consistency similar to firm jelly. The weight of the brain does not directly correlate with intelligence. A heavier brain does not necessarily indicate a more capable mind. What matters more is the intricate network of neurons and synapses packed within it, across all humans, regardless of the exact volume or mass. The brain maintains a remarkably similar number of neurons, enabling the vast array of cognitive abilities humans possess. Interestingly, after the age of 20, the human brain gradually decreases in mass, losing approximately 1 gram per year. This loss is subtle and often has little impact on cognitive function until much later in life, suggesting that the brain is built with considerable resilience and redundancy. Throughout development, the brain grows rapidly. From birth to adolescence, brain weight increases steadily, reaching its peak during the teenage years. Graphs illustrating this growth show a sharp rise early in life, leveling off as adulthood approaches. Notably, the male brain is, on average, consistently heavier than the female brain from birth onward. Despite these differences, brain function across genders remains largely equivalent, emphasizing that size alone does not dictate cognitive capacity. When examining brain weight in proportion to total body weight, an intriguing pattern emerges. At birth, the brain constitutes a much larger percentage of body mass compared to adulthood. A newborn's brain may make up as much as 13% of total body weight, highlighting its vital importance in early life. As the body grows, this percentage diminishes, eventually stabilizing around the adult figure of 2%. Within the confines of the skull, the brain is carefully housed in what is known as the intracranial cavity. This cavity contains not only brain tissue, but also cerebrospinal fluid and blood vessels. Cerebrospinal fluid plays an essential role in protecting the brain, filling the ventricles and surrounding spaces to act as a shock absorber. It also serves to remove waste products and deliver nutrients, helping maintain a stable internal environment crucial for brain function. The contents of the intracranial cavity are distributed approximately as follows: 80% brain tissue, 10% blood, 10% cerebrospinal fluid. This balance is vital. Any significant shift in these proportions can lead to severe medical conditions, such as intracranial pressure, emphasizing the delicate equilibrium the body must maintain. The brain itself is a complex composite of substances, consists largely of water, which makes up about 77 to 78% of its total composition. Beyond water, the brain is composed of 10 to 12% lipids, vital for building cell membranes and insulating nerve fibers. Proteins constitute about 8% of the brain's mass, forming enzymes and structural components. Smaller amounts of carbohydrates and soluble organic substances complete the brain's makeup. This intricate biochemical structure supports everything from basic survival functions to higher-order thinking and creativity. Physical dimensions of the brain vary slightly among individuals, but on average, the human brain measures about 6 inches wide and about 5.5 inches long. Although the surface of the brain appears convoluted with ridges and grooves, this folding increases the brain's surface area, allowing for a greater number of neurons to fit within the limited volume of the skull. Brain size, therefore, is not just about bulk, but about efficient design. More surface area means more processing power, and nature has elegantly packed as much capacity as possible into the available space. This folding also ensures that higher cognitive centers are preserved, while maintaining a compact form that fits neatly into the cranial cavity. The brain's resilience, however, is not infinite. Lifestyle choices can significantly influence its health and structure. Recent studies have shown a direct link between alcohol consumption and brain shrinkage. Comparative imaging studies have revealed that people who consume large amounts of alcohol over time tend to exhibit noticeable reductions in brain volume. In detailed examinations, former drinkers and heavy drinkers show the greatest degree of brain shrinkage. Interestingly, moderate drinkers, those who consume alcohol in small, controlled amounts, do not exhibit the same level of brain atrophy. This suggests that excessive alcohol consumption leads to more permanent damage, whereas moderate or abstinent lifestyles allow the brain to maintain its structure more effectively. The effects of alcohol on the brain are evident in MRI scans. In images comparing the brains of a normal male and an alcoholic, the differences are stark. The brain of an alcoholic appears shrunken, with wider grooves and less dense tissue, reflecting significant loss of brain mass. Alcohol also impairs the brain's natural healing mechanisms. In severe alcoholism, the brain's ability to recover is hindered, and prolonged withdrawal symptoms prevent the regeneration of damaged tissues. Moreover, the poor nutritional status often associated with alcoholism exacerbates brain atrophy, creating a vicious cycle of damage and decline. Brain volume loss is not solely a product of alcohol consumption or aging. Other lifestyle factors such as chronic stress, poor diet, lack of exercise, and sleep deprivation can also contribute to gradual brain shrinkage. Conversely, engaging in regular physical activity, maintaining a balanced diet rich in nutrients, managing stress effectively, and getting adequate sleep have all been associated with preserving brain volume into older age. Cognitive engagement is another powerful protector of brain health. Activities that challenge the brain, such as learning new skills, solving puzzles, engaging in social interactions, and pursuing intellectually stimulating hobbies, promote neurogenesis, the birth of new neurons, and strengthen existing neural connections. Despite its vulnerabilities, the brain demonstrates a remarkable capacity for adaptation and resilience. Even in the face of injury, disease, or degeneration, the brain can reorganize itself, rerouting functions around damaged areas, a phenomenon known as neuroplasticity. This ability underpins rehabilitation efforts and gives hope for recovery following strokes, traumatic injuries, and neurodegenerative diseases. Ultimately, the human brain is a marvel of biological engineering. Brain's small size relative to the body belies its immense complexity and power. Brain orchestrates every heartbeat, every breath, every thought, and every dream. Brain is protected by layers of bone, fluid, and membrane. It works tirelessly from birth until death, adapting, learning, and evolving with experience. As science continues to advance, our understanding of the brain's composition, energy needs, and vulnerabilities deepens. Each discovery brings us closer to unlocking the secrets of cognition, emotion, memory, and consciousness. The journey to fully comprehend the brain's capabilities and limitations is ongoing, a testament to the boundless curiosity and determination of the very organ seeking to understand itself. This exploration into the human brain's size, energy use, and protection has been proudly prepared for World Peace TV Neuroscience, dedicated to spreading knowledge and fostering a deeper understanding of the organ that defines humanity's shared experience.